Today we are going to learn about similar figures. Similar figures are the same shape but different sizes. Their sides are proportional. This is how we tell if they are similar or not. Their corresponding angle measurements are congruent. That means that this angle, the bottom left angle, is congruent to the bottom left angle of the other triangle, of the similar triangle. And this top angle is congruent to this top angle. Even if you notice they're different sizes, the angles are still congruent. No matter their size, they will still have the same degree angle. So the way that we find whether a shape is similar or not is we set up a proportion. We have similar corresponding sides, so meaning that this side is corresponding to that side, and this bottom measurement is corresponding to the smaller right triangle's bottom measurement. So I put little hash marks to let myself know how I'm going to set up my proportion. I'm going to put the first hash mark over the second hash mark. So I'm going to do the big triangle first. I'm going to say 6/10, first hash mark over the second hash mark, is equal, and yes, we will be setting up proportions every single time, the first hash mark of the small one to the second hash mark of the small one. So then I see if they're similar. If they're similar, it means that the ratios are going to be equivalent to each other. Can I get one ratio to the other? So let's see. If I divide this 6 by 2, I get 3. Check. What I do to the top, I have to do the bottom. So when I divide 10 by 2, do I get 5? Yes. So our answer is yes. These triangles are similar. Number 2 is the same thing but with rectangles. So again, it's asking are these shapes similar? I'm going to do the hash mark thing. I'm going to put the right long side as one hash mark. So the right long side on the small rectangle as one hash mark, and the bottom ones as 2. So I'm going to tell myself that I'm going to put 1 hash mark over 2 hash marks. This is going to come in handy when we get a lot of different sides of different numbers that we have to look at. So I'm going to put the first hash mark of the big rectangle over the second hash mark of the big. So this is the big is equal to the little. First hash mark of the little over the second hash mark of the little. So then I say, how do I get one number to another? Is there somewhere in here that I can get one number to another? Yes, but if we don't see that, we can simplify. So I can say, what number goes into 12 that also goes into 8 evenly? Well, that is 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So here, now I can say, can I get one number to another? Well, this time I might actually see it, and that is yes. If I multiply 2 times 16, that's going to give me 32. So what I do on the bottom, I have to do on the top. And when I multiply 16 times 3, I get 48. So how I'm going to write that this is a no is I'm first going to say, well, I got 48, and that is not equal to the number I needed to get, which was 50. So my answer is no. This is how you prove it. This is how you will show us no. 48 is not equal to 50, therefore it is a no. These shapes are not similar. I would like you to look at this one. This one looks a little different. This one has a triangle inside a triangle. So if we look at our long side on our big triangle, that's going to be this 8. Our little triangle is right here. So our little triangle's long side is this 4 right here. Our big triangle is going to have a long side, and this is represented by the X. So here is our long side, our second hash mark. This little triangle's long side is represented by this 7 right here. So there's our second hash mark. So we're going to put 1 over 2. Our big triangle is 8 over our second hash mark of x is equal to our first hash mark of our small triangle over our second hash mark of our small triangle, which is 7. Now notice we have an x. Our question here is to find the missing side. So it wants us to find our base of our triangle. We do this just like we do any other proportion finding x. We say, how can I get 8 to 4 or 4 to 8? I like to work on the side where there's 2 numbers, so I'm going to say, how do I get 4 to 8? I multiply that by 2. What I do on the top, I have to do on the bottom, so 7 times 2 equals 14, and I'm showing you how to show your work every single time. X equals 14, and we'll box that final answer. Number 4 is a different way of looking at it. It gives us lots of numbers, and this is where I say the hash mark is going to come into handy. We have a big triangle outlined right here, and we have a small triangle outlined right here. So, I would like you to try this. Put the hash marks where they go, identifying the base, the height, our different sides, and when you have finished setting up this proportion and finding x, please press play and we will see how you did. Okay, so I've set this up 2 different ways. I have set it up as if we were putting our first hash mark over 3 or our second hash mark over 3. So check your proportion that you set up. You should have 6x equals 9 over 15 or 8x equals 12 over 15. As you can see in both cases, we are going to get x equals 10. And this is where our hash marks are going to come in handy, so we can identify that this height is the same or similar to this height over here. Let's go on to number 5. Number 5 says a building is 36 feet tall and casts a shadow of 18 feet. A tree casts a shadow of 9 feet. How tall is the tree? So here we're talking about a building's height, and we're talking about a shadow. So I'm going to write a ratio of height over shadow. So if we go back in the problem, we have a building's height of 36. I'm going to put that on top of my ratio. And its shadow of 18. I'm going to put that on the bottom of my ratio. And we're saying that these are similar. So this building's height and shadow is similar to a tree's height of x, because it's asking how tall the tree is, and its shadow of 9. So height over shadow, 36 over 18 equals x over 9. So because these are similar, we're able to find x in this proportion. We can say, how do we get 18 to 9? If I divide 18 by 2, I get 9, and what I do to my denominator, I have to do to my numerator. So I take 36 and I divide 36 by 2. So when I divide 36 by 2, we should get 18. So our x equals 18. We have our final answer, so we're going to box it. X equals 18. What are we talking about? We're talking about the height of the tree, so 18 feet. Here on number 6 and 7, on number 6 you are going to figure out, is the following similar figures? So is that a yes or a no? On number 7, it is just like the problem we did on number 5. You're going to read through it, set up your ratio and your proportions. Please show all of your work, and we will check these tomorrow in class.